Hey, welcome back to Fan Mama Physics. This is going to be example 6 in 6.2 part 1, Newton's universal law of gravitation. So let's get on with example 6. Calculate the gravitational field strength halfway between the Earth and the Moon. Okay, so halfway between the Earth and the Moon. This is not too bad. Okay, let's draw a picture, of course. So we got the Earth over here. And the moon, let's say it's over here, okay? We're actually told the orbital radius, which I mentioned what it represents in the previous video. The moon's orbiting around the Earth at a set distance, and the orbital radius is exactly the distance from center of Earth to center of the moon. And the, where did I have the number written down, is 3.84. 3.84 times 10 to the power of 8 meters, okay? So we want to find the gravitational field strength in between the two, so exactly right there. And as you may expect, the gravitational field, we want a gravitational field strength. So in fact, we want to find the G, the gravitational field due to the Earth. And we're going to have some that's from the moon, gravitational due to the moon. And we're going to have to find the vector sum of the two, since the gravitational field strength is technically a vector, just like acceleration is like a vector as well. So to find the resultant vector of the two, we have to add the two vectors up. Now, you might notice that the vector, the gravitational field strength directed at the Earth is going to be stronger than the gravitational field of the moon. So I'm going to get the resultant gravitational field strength with GE minus GM, okay? In which the gravitational field of the experienced by the Earth is going to be big G times mass of the Earth, and in which the radius over here is going to be exactly half of 3.84 times 10 to the power of 8. So I'm going to do in brackets, so 1/2 of 3.84 times 10 to the power of 8. Very ugly writing. Don't forget to square this. And this I'm going to subtract it by the gravitational field strength of the moon over and then don't forget the distance of separation will be also half of the distance to that of the Earth. Okay, so it's exactly halfway. So from here to there is half, from there to there is half as well. So let's put some numbers in which the gravitational constant is your 6.67 and times 10 to the power negative 11. Mass of the Earth is 5.97 times 10 to the power 24 kilograms. And over this big ugly number, which is half of that. Actually, what is half of 3.84? 1.92. Okay, so that's 1.92 times 10 to the power of 8. All of that squared. Minus 6.67 times 10 to the power negative 11. And the mass of the moon, I believe, is 7.35, was it? 7.35 to the 22. 7.35 to the 22. And all divided by 1.92 times 10 to the power of 8 squared, because this is halfway. Okay, time to put everything into the calculator. I get my final answer to be 0.01066688, which is going to round up to 3 sig figs. 0.0106 rounds to 6 to a 7 Newton per kilogram. And I would actually say the directions here towards center of Earth, okay? Because this is a vector that we're talking about, okay? So unless it asks for the magnitude, then you're fine, but it's not. So please include directions when a vector is involved. Okay, so I don't think that was too bad. You just have to do vector addition for gravitational field strength. Otherwise, I think it's going to be very similar to example 7, where you have to add up the vectors in a 2D plane instead. So stay tuned for example 7. Thank you for watching. Good luck, Fat Mama Physics, signing out.